Scouts Outreach InvenTeam. My name is Lucas Lohman, and I'm the communications lead. So our team is composed of 13 high school students and 2 educators from Southern California. We came together in October of 2017 as a JV InvenTeam to learn the invention process. A year later, we applied for and successfully received the Lemelson-MIT EurekaFest grant. And since then, for the past several months, we have been working on bringing our invention ideas to life.
Hi everyone, my name is Anne and I'm the team's administrative lead. So a little bit more about the team dynamics. So we have students from 2 high schools, one being the California Academy of Math and Science and the other being Chadwick School. We also have 2 educators as well as a technical review board, which we consult for medical advice and just consumer advice in general. And so the target of our project is sleep deprivation. So we wanted to find something that really impacted our community, and we looked to ourselves, high school students, and decided that sleep deprivation was a pretty big problem that we have.
So to gain a clearer understanding of and greater prevalence of sleep deprivation in our community, we conducted a survey on local high school students and found that they slept an average of 5.9 hours per night, far below the recommended average of 9 to 9.5 hours that every growing teen needs. This can cause an array of physical and mental health effects, such as heart disease, stroke, and depression. A particularly landmark case was conducted on Virginia high school students and found that 30% of students that slept 6 hours or less per night experienced symptoms of depression. 1 in 10 of those students attempted suicide. So clearly, getting adequate sleep is a highly important goal that we are all working towards. So what's the solution? Well, the first solution is pretty obvious: get more sleep. However, for teens that are balancing school, work, sports, and other activities, getting more sleep often isn't an option. So instead, we're looking to optimize sleep quality. And in doing so, we hope to optimize rest and recovery for teens without compromising their schedules.
My name is Kathleen Saxon, I'm Sustainability Lead. So we did multiple things in order to arrive at our solution. First, we took a survey of our peers at our school and found just how prevalent sleep deprivation really is. We also did a lot of research, so we looked at patents and looked at scientific papers. And we also did a lot of market research, so we looked at sleep devices such as the Nokia Sleep Pad and the Fitbit, and we found that all the devices on the market are passive. So they just monitor your sleep, they don't do anything to improve it. So they'll say, you slept for this long, that's not enough, go to sleep earlier. Or they'll say, you spent this much time in this sleep stage. But we wanted to fill that gap and make a product that was active and improved your sleep in real time. We also, once we decided on this goal, we got professional input from our technical review team, and we visited a sleep lab to find out how sleep is measured in a clinical setting. Based on all the work we've done, we invented Delta Sleep. So it consists of a headband and an earpiece, which measures sleep factors during the night, such as core body temperature, eye movement, heart rate, and brain waves. There's also a wristband, which applies a temperature stimulus to the user's wrist during the night. There is a mobile app, which the user plays during the day. There's reaction time games, which help measure alertness. And then all the data we collect from this go into a personalized sleep profile. So that's an algorithm that determines the temperature stimulus applied during the night. In order to develop and test our device, we created Jeff, which models biological data so we can measure them with our device and test it.
So real quick, by a show of hands, how many of you feel like you get 8 or less hours of sleep? Okay, so a lot of you. And to kind of explain how our device, Delta Sleep, works, we're going to have Aaron here model the typical high school student who's struggling to stay awake in class. Okay. And you may be wondering where Delta Sleep came from. That is from the different sleep stages. The deepest stage of sleep, which is the most gets you the most recovery and the most revitalizing, is when the brain is emitting delta waves. So that's kind of where we based our name off of. But so Aaron will be using the Delta Sleep device today. And first, at night, he'll put on the wristband and the headband. And when he puts the headband on, that's going to be measuring the different sleep factors we mentioned earlier. So that will produce us some sleep data. And with this sleep data, we're feeding it through a sleep profile that is an intelligent algorithm that will modify the temperature stimulus given his current parameters. That temperature stimulus will try to affect the current sleep status and drive him into a deeper stage, and so that will be a continuous loop throughout the night. And then in the morning when Aaron wakes up, he'll be prompted to play the alertness games, as we mentioned, whether it's a reaction time game where you have to push a button or you're rating a scale 1 to 10, that is a KSS scale that's an official alertness rating. This produces us with daytime data, and that gives us kind of validation of how well you slept. The daytime data and sleep data are then combined to a sleep score, which is looking at how alert they were through the day and what proportions of deep sleep you got that night. That sleep score then allows us to use artificial intelligence to generate new sleep profiles. So we'll be using a genetic algorithm that creates a population of sleep profiles and sorts them based on their sleep score. So the best ones come to the top. These are then bred and added mutations that fill the bottom, and then they're tested again. So the best sleep scores sleep profiles will always be fed into the following night's sleep to optimize the user's sleep.
So taking a look into some of our building throughout the last few months. So these are just some pictures of our team and our progression from left to right. So as you can see on the left, we're really learning how to work with all the code that we need. So one of the biggest parts of our project is to collect a lot of data and process that data to apply our stimulus. So we needed to learn how to put this data into a cloud database, which was actually pretty complicated. And we also have a lot of mechanical components to our project. So we also learned how to solder and just work with all the material that we needed. So we also did community outreach too, because sleep deprivation is such an important issue for us. We wanted to make sure that people in our community knew more about it and how it impacts high school students. So while we were learning to build our invention and all the programming, all the code, we also wanted to make sure that our problem was really brought to our community. And so finally, on the right side, you can see our current prototype. So that's Jeff, as well as our wristband that Aaron was using.
So in order to test our device, we sent simulated data to Jeff. And we first measured it with your traditional measuring devices, such as a thermometer you would use for yourself. And we did this to confirm that the signals he was outputting were similar and comparable to that of a human. We then measured it with our actual device, and we compared the measured data with the simulated data. And they were comparable, so we could say that our device was accurately measuring sleep factors. So overall, at this point in the process, we can say that we have a device that accurately measures sleep factors, an app that assesses alertness, a wristband that applies a temperature stimulus, and an AI system that can determine the temperature stimulus applied at night. While we cannot say that we're improving sleep quite yet, we do have a system in place that we can move to human testing, or it can be confirmed there. And then in terms of sustainability, we tried to keep a few sustainable practices throughout our project. So we designed for disassembly as much as we could, which means we made parts easily recoverable. So for example, several of the parts from our first iteration were able to be taken out and reused in later versions. And this limited virgin materials and waste. In addition, we used additive manufacturing, so we 3D printed as many of the parts as we could, which prevented us from having to resize or alter conventional parts that we would have bought, which would have produced more waste. And then as we progress with our device, we hope to further minimize the energy consumption of the device itself.
So taking a look into the financial aspect of our project, of the $7,000 that we received from Lemelson-MIT to build our invention, we used the vast majority of that for our prototype development. So that involves all of the models that we had to make, all the electronics that we bought, and all the parts that we used to build our actual project. In total, from community donations and outreach, we received about $28,000 of money, and that's both in-kind donations, such as different kinds of software that we received from professionals, as well as monetary donations.
Some of our plans for the future we have set out here. On the technical side, we want to improve the comfort of both the headband and wristband to just make it less intrusive for the user and making it easier for them to sleep. For the stimulus itself, we're looking at a different form or function where it's either in like the shape of a scarf or it's a completely different thing such as sound instead of temperature. And we also want to refine the AI just so that it can always learn quicker quicker and give it a new sleep profile, a better sleep profile as soon as possible. And that will come with more users using it, giving us a wider data set to work with. We also want to miniaturize and consolidate the device instead of having two separate things having to communicate with each other, possibly down to one item, just to make it easier for the user to use. On the administrative side of things, we already have a provisional patent, and we really want to go for a full patent just based on our device. And we want to connect to many consumers out there and see what they think about our device, and also move our device into human testing.
Throughout the course of our project, we have received the generous support from several people and organizations. In particular, we'd like to thank the Lemelson-MIT program for providing us with support, funding, and guidance throughout our invention process. We would also like to give special thanks to Frank Yang, the founder and CEO of Simple Human, for funding our EurekaFest travel expenses. Lastly, we would like to thank our two educators, Dr. George Kirkman and Bing Jiang, for their countless hours of support and guiding us through every step of the process. Thank you all for listening, and from the Rolling Robots Outreach InvenTeam, sweet dreams.